Uh, so before we begin, I'd like to remind everyone that we'll be recording this webinar. So my colleague has just started recording this session. Okay, so welcome everyone. Thank you for joining us this Friday morning. It's very nice to see so many attendees, especially those who came quite early on this morning. So my name is Samuel Cheng. I'm a research fellow at the Lee Kuan Yew Center for Innovative Cities. And this webinar that you're joining today is jointly organized by both the Lee Kuan Yew Center and also SUTD. So we named this series, this webinar series, City Pioneers series, which is actually our way of engaging with the greater community, especially with students pre-university, to introduce some of the cutting-edge work that SUTD is doing, in particular related to the urban environment, so urban studies and urban research, to see how all these innovations are changing the way we see the world, how we understand the world, and also to help us better appreciate our city and also our community. So as part of the series today, which we have covered many other topics, now we're moving on to the next frontier of additive manufacturing, and we'll be talking about 3D footprinting this morning. And it's really our honor to have Prof. Kai to give us this webinar lecture to share with us more about the work, the cutting edge work that he's doing with 3D footprinting. So Prof. Chua is the head of pillar for EPD, which is engineering, product, and product development. Yeah, and he's also the Chang Sun-man Chair Professor at SUTD. So his research area in 3D printing and rapid prototyping and additive manufacturing makes him one of the foremost experts globally in this area. And he is in SUTD today. Okay, and he will be sharing with us the work that he's been doing. Yeah, and I hope it will be of interest and also to spur your curiosity in this area. So without further delay, pass the time to Prof. Chua.
Hi, thank you, Samuel. Can you all hear me loud and clear?
Yes, yeah.
Okay, thanks, Samuel. So as what Samuel has said, I will be presenting in the next half an hour what SUTD is working on 3D footprinting. So about myself, I've been in 3D printing for almost 32 years now. And in the last 30 years, I published a lot of work in the journal, conference, books, book chapters and patterns. In fact, I'll show you one of the books that's coming up next month. We academics, when we publish, we try to influence the research in a certain direction, and as such, our papers will be cited. And this is a measurement of our impact. So I have more than 20,000 citations and a H-index of 72. So according to Web of Science, I'm the world's most published and most cited scientist in 3D printing. And you can see my contact there, my email, my phone, as well as my WhatsApp. So feel free to contact me even after today. So this is a slide to show where I am in the world of 3D printing. So in terms of publications, in terms of citation, I'm ranked #1 in the world. And we have 2 persons in SUTD in the top 50. The other one is David Rosen. So my topic outline, as you can see today, is quite a lot of things I'm going to cover, from footprinting, what exactly it is, the timeline, what has been done in the last few years, and you can see later the trajectory is actually going up. Why? What was the main motivation behind footprinting? Very briefly, how does 3D footprinting works? It's very not much different from what you are doing when you're printing plastics. What are the applicable technologies for footprinting? What is the ideal properties? And my focus will be very much the types of printable food materials I think will be of interest to you. Those that are easily printed, like chocolate, not so easy to print traditional materials, a lot that we eat every day, like broccoli, pai tai, as well as dory for fish, and mashed potato for carbo. Now, the world is also getting very excited about alternative ingredients. That means, what if we run short of chicken, which we recently were threatened, and can we just use proteins or even insects to give us the proteins that's needed? And food waste, one of the biggest issues today. A lot of, in fact, 1/3 of the world's supply of food actually goes to waste, and what's next in the horizon. And I'll share also beyond that a little bit of things we are doing, like the conference we're organizing and the competition we have just finished. In fact, our competition has been covered in CNA. Not sure whether you watched it. It was, I think, 2 nights ago at 9 o'clock on CNA, and last night was repeated at 7 p.m. So what is 3D food printing? As you can see from this slide, we are printing things layer at a time, and you can print different kind of geometries. And basically, it is a standard 3D printer that most of you may be familiar with. Each of these printer can now cost you only a few $100s. The only difference in this case is that instead of printing plastic, metals, or something else, the ingredient or the ink that you use now is food ingredient. So, and you print it a layer at a time, and therefore you construct a 3-dimensional item, which is in the case, of course, is your dish. Now, as utility, we have coined a term called digital gastronomy, which means we go beyond printing, because we believe that in the day which we are living in today is called Industry 4.0. And many aspects of Industry 4.0 can be incorporated in this printer so that it goes and it broadens to what we call digital gastronomy. Now, the fact is that it is digital. We are doing a dish digitally on a software, and therefore you can manipulate voxel by voxel how you can build this 3-dimensional object. And because you can manipulate it in that way, you can actually bring in other aspects of Industry 4.0. For instance, AI. AI can be used to optimize your material. AI can be used to optimize your design. AI can be used to optimize your process. So these are all the aspects of things where we bring in robotics, AI, Internet of Things, machine learning, all the nice things in 3D to complement 3D printing to build out what we call digital gastronomy. And of course, most of you are students here. We welcome you to intern with us. And if you have graduated, you're interested to do PhD, please feel free to contact us. So with this technology, your food can be designed and fabricated to meet individual needs. When we started this work about 7 years ago, the focus was healthcare. We were trying to meet a very specific group of people, and I'll share it with you a little more later. Certain health conditions that require this kind of food. And of course, there are others that go beyond it, that you need certain nutritional content like sportsmen or soldiers, then you can actually customize it. So the idea is to integrate additive manufacturing or 3D printing with other kinds of Industry 4.0 technologies into what I call digital gastronomy. So things really can be custom designed without the need for molding. I think many of you are familiar with what a mold is. So a lot of the food that we see today that we eat, like ang ku kueh, is actually a mold, and that's why it's always with the same shape. Or eat your curry puff, again, a mold is used. In this case, there's no indirect means. You don't need a mold. You actually print the object directly. And of course, direct is always preferred to indirect method. And a mold is always the same shape, but if you 3D print, you can print a different shape each time without human intervention. And it's important that this entire method, like all 3D printers, is fully automatic. So the chef itself can be can leave the printing of the food while he can focus on maybe high order complex job. So it is not meant to replace the chef. I call this the digital chef. So the printer itself will aid the chef in helping with maybe some mundane, some automatic tasks. So you look at timeline, 3D food printing is relatively new compared to maybe printing in aerospace, marine offshore, building and construction, manufacturing industries. So as far back as 7 years ago, I bought my first chocolate printer. You can see the chocolate is printed. Chocolate is relatively a suitable material for printing, and I explain why later. And then we move on to other things. You can see the yam and the sweet potato. In fact, we printed quite a lot of vegetables by now. Broccoli, pai chai, carrot, a whole lot of vegetables we've done. Now, I want to point you out to the two very important statistics on the right-hand side. Firstly, at the top, you can see the market size. The market size is growing bigger and bigger each year. And by 2023, which next year, it will grow to a value of 525.6 million USD. Now, the bottom graph that you see, we track the number of publications in 3D food printing. And it started with very small in 2015, just only 5 papers. and has grown rapidly. You can see it's the most exponential increase to today, probably is crossing above 100 papers in this area. And of course, our group who has contributed quite a number of papers at this area. Now, why? What is the motivation? Why do we go into food printing? I think the whole idea about this is digital. Food is today not digital by any means, but the fact that if you can design digitally, then you can actually customize it voxel by voxel. Now, I say voxel and not pixel. Pixel is basically flat, X, Y. But when we talk about voxel, it's X, Y, and Z, meaning that there is a layer thickness to it. So imagine instead of your yakun bread, where you just have one layer of kaya, can I have within my dough pores, which I can insert peanut butter, margarine, all kinds of different ingredients into this three-dimensional structure. So you can absolutely customize your bread with different kind of taste. So of course, if you go beyond that, in certain category of people like sportsmen, they need certain kind of nutrition, or the soldier taking in their data, the physiological data, you can actually customize a snack for them. So this is really the power of 3D food printing. Now you can simplify the food supply chain. Today, we all know supply chain is being choked because of the pandemic. When we talk about almost 3 years ago, when the pandemic first started, a lot of our supply chain was choked. And in fact, in 2020, we were looking at even the nasal swabs that's used to check whether one has got COVID or not. That was initially a problem because the two major companies that supply nasal swabs in America and Italy were badly hit by COVID themselves. So how do we, Singapore, meet this supply chain choke? So by merely 3D printing our nasal swabs. So you can see that with food supply, an Eskimo who maybe desire our chwee kueh can actually download this menu, and with the right ingredients, they can actually print it there and there in ice cold condition. So the whole idea is that you can print on demand anywhere in the world to satisfy your interest in a specific food. And this food supply chain will allow you to also overcome some of the shortages. Like, suddenly there's a supply of a chicken issue that we face only very recently. Now, food is always print on demand. Therefore, you can actually extend the shelf life. That means if you don't use it because it's a perishable, then you can keep it longer. But when you need it, then you print on demand. So it helps you to extend shelf life. In fact, one of the earlier projects by NASA was to actually print a food printer on space mission, which are long. And when they need it, they will use a food printer and print the food. And if you look at a movie, if you have watched this movie called Martian some years ago, the astronaut, he was the only astronaut who survived on that mission. And he survived because he learns botany in his undergraduate days, and then he managed to grow some potatoes. But the other alternative was to have a food printer, right? And then you can print whatever food you need. Upcycling of food and reduce wastage are two quite related topics. The whole idea is that the numbers are actually astronomical. A lot of the food that we produce on a daily basis, 1/3 of it in the world is wasted. So examples, there are two kinds of examples in terms of waste. There are those that maybe the stems are too hard. And recently we had our second competition. We have a competition a bit like MasterChef, but with a twist. We bring in technology. So stems and stalks, which are very hard to eat, the veggie farm actually throw them away. So why don't we bring it back into the food chain? That's one kind of wastage. Fruits which are overripe. There is another kind of wastage, which is those byproducts. If you drink coffee, you get coffee grind. If you drink tea, you have tea leaves. If you eat tofu, actually in the production of tofu, it generates a lot of this byproduct called okara. So instead of throwing all these things away, you can bring them back into a food chain, and therefore they are actually consumed because they still have that nutritional value. And it's how we think upcycling and reduce wastage will help in our promotion of food sustainability. How does 3D food printing works? Very simply, it all starts with design. So you have a virtual model that you see in this picture on the left. So using a 3D model like AutoCAD, CAD, CATIA, there are easily 30, 40 different commercial CAD/CAM packages that you can do a 3-dimensional design. Then because today, by and large, many of the printing technology works on the basis of a layer, they actually slice it layer by layer. And then it actually will use this instruction to instruct the printer to print it. Now, there are many different kinds of printing technologies, but by and large, most of them are printed layer by layer. But there are also different ways of printing layer by layer, which I'll share shortly. Now, once it's loaded into your printer, the printer works on the instruction of your model, and then it delivers the layer by layer printing. And of course, in this case, a chocolate is used. You have a 3D heart-shaped chocolate printed. Now, I've shared earlier, there are actually, according to ASTM, 7 different 3D printing technology. By and large, most of the work we have seen around the world commercially, they are based on extrusion, the one that you see on the left-hand side. By and large, a lot of papers are published based on extrusion, but there are actually other potential technologies that you can use. You can use inkjet printing, you can use selective laser sintering. By the name, you can tell that a laser is used to sinter powder together. And on the last one, binder jetting is basically to deposit small droplets of binder. And upon impact, this binder acts as a glue to join the powder together. So these are all various methods can be explored in food printing. Now, let me share a little bit more about extrusion. So you can see in these 2 examples that have been published by my colleague, he has done both hot and cold extrusion. By hot, it means heat is involved. So the heat is involved in this case to melt the chocolate. So when you use, let's say, a extrusion base, most of them come in the form of filament. So it can be a filament or it can be just a bar of chocolate. The whole idea is you're going to melt it so that it can be extruded. And when it comes to the end of the extrusion, there's a nozzle. The orifice size can be controlled. So of course, the smallest the size you use, the better the resolution, but the compromise, it becomes lower. So you can print them layer by layer. And upon deposition of your chocolate, it's cooled and therefore it hardens. And that's how you create your 3-dimensional shape. Now, if you work on things like milk, which we have also done and published in the paper that you see there, it is easier because you actually do not need heat, and we call it cold extrusion. And with that, we can actually take advantage of the properties. Now, all this work relies on one very key area that's called rheology. Rheology is basically the understanding of the extrudability of the material. So viscosity is key. So when it's very viscous, it's not so good. So you need to control it by playing with the heat, or in certain cases, the material properties, in this case, the milk. And of course, without temperature control, it actually saves cost, and it's user-friendly, it's low cost. Now, the ideal properties are for food ink, the best is self-supporting. If you have some knowledge of 3D printing, you will realize that if you are printing an overhang, you actually need a support. Otherwise, due to gravity, it sags or even deforms. So the best is you orientate it, or if you can redesign it so that it is self-supporting. Why? Because the minute you have a support, you have to think about removal later. So the less, the better in terms of supports, because you don't waste that much material and you don't have to worry about removing them later. Now, heat is a very interesting thing. So one of the things at SUTD right now is that we are developing our own printer, because we see a lot of commercial food printers out there do not have this heat capability. And I think for food, heat is very important. If you can develop the heating capacity, then you can even heat layer by layer, and you can vary the texture of the food that you're going to consume. Now, I'm going to share the 4 kind of food inks that we have been working on at SUTD. First is natively printable, which I've shared a little bit already, chocolate and milk. The large part of our work is actually focused on this second one, which is non-printable traditional materials. And we do it for a very specific issue, which is healthcare issue facing an aging population. More and more folks will go into this category where they're probably eating the normal food that you and I eat. So for instance, if they eat their favorite mee pork, they will get choked on a fish ball because it's not something that they can consume. So those patients who have stroke or dementia, they will need this kind of puree diet. And instead of just relying on porridge every day, having a nice visually 3D printed food which they are familiar with, like your green peas, your spinach, your broccoli, and as well as delivering the kind of nutrients that they need will be most important in the area of healthcare. Now, moving on to the thing on the right, alternative ingredients. This is a growing area of interest because of the fact that sometimes we may just have a problem in terms of supply chain. For instance, our chicken supply is being cut. Can we look at alternative? Where can the proteins come from? So of great interest in recent years is can we take proteins from plants? Can we take proteins from insects? And last but not least, food waste, which I mentioned, ugly vegetables or fruits which are overripe or stale bread, or as well as some of the byproducts. So for instance, you eat your orange, you throw away the peel. You eat your jackfruit, you will throw away the jackfruit seed. But a lot of these still have nutrients that you can actually recycle and bring them back into the food chain. So let me cover the first, which is natively printable food materials. So we have done work in chocolate and milk, and others in the world have done things like dough and cheese and so on and so forth. So chocolate, now how different is it? Not much. So what I've shown you earlier is actually the same here. So going from design and then basically implementation by giving the instruction to the printer to achieve it layer by layer, and then in deriving your three-dimensional chocolate in this case. Now, there are benefits and limitations during chocolate. It's very easy for you to customize all kind of shape, and maybe you have a birthday, you can make a figurine of the person, and you can always enjoy your complex 3D design. But you will find that one of the Achilles heel or weaknesses in 3D food printing today is it is not mass production. So if you want something that is produced by the millions in days, then this will be too slow. So upcycling is actually a major thing that all the research groups are working on, including us. Now, the chocolate, therefore, can be time-consuming due to heat complications. So the chocolate has to be heated, and then, of course, once it's printed, it has to be cooled to maintain that shape. So these are some of the work that has been published by my colleagues. You can see it's printed all kinds of chocolate stuff. These are the things that Cheng Pao, our PhD student, has been working on. He has also published a paper based on milk products. And these are some characterization work. So you can see that it's actually science-based. It's not something that just go to a printer. You have to look at various parameters that you have to optimize so that you can print a product which meets your requirements. So you can tell that Cheng Pao's favorite movie must be Star Wars. So you can see some of the favorite characters being printed here made of milk. And can you combine multiple materials? Yes, you can see here we actually combine milk and chocolate, very yummy. And you can combine it three-dimensionally, not necessarily layer by layer like your kueh lapis. Within a single layer, you can decide to have both chocolate and milk. And can you do more than two? Yes, if you have 5 noses, you can actually have 5 different materials. And I think all of us are familiar with chicken rice, nasi lemak, all this food has usually multiple ingredients. So you can easily configure them and print them in a dish. Now, this is the bulk of the work we have been working on, non-printable traditional materials. In other words, there are actually technical challenges to print this material. They are not so easy to print. So one of the recipes that we have formulated for different kind of materials, we use different kind of hydrocolloids and in different proportions. So these hydrocolloids are actually commercially available. They act as a function of a hardener so that you can maintain the shape. They are commercially available and therefore they are actually consumable. So they are safe to consume in adding. So our focus was really on a very specific group of patients that suffers from the fact that they cannot eat food that are too hard. They will be hard to digest and even they will get choked. So we work on a lot of vegetables and fruits. And some of it has very high water content as we found, and therefore we need additives. In this case, different kind of hydrocolloids that you see at the bottom. Now, can you also add supplements like flavor and nutrition? Yes, you can actually incorporate that into your ingredients. Either you can pre-mix it or you can actually print it as we go along. So you can have better printing outcomes in terms of your shape, surface quality, better texture, as well as resistant to post-processing and prevent the water from leaking. So these are some of the things. So the whole idea is that A person who suffers from stroke, who cannot eat the usual food that you and I eat, need not just rely on porridge every day. And then actually we're looking on the aspect of dignity, so that when you age gracefully, you can still have the food that you like, your broccoli, your mashed potatoes, and your dory fish. So the idea is to only appeal to the eyes visually, but also appeal to the nose, aromatic, and then of course making it appetizing. And lastly, it's safe. So this is something very important. It's reproducible because you're using a printer. So the whole idea is reliability. 100 times you print it, it should 100 times deliver the same requirements that you have needed in terms of visual, in terms of taste. So this is what we do in the methodology. So in this case, we use, I believe is carrot or sweet corn, and then you basically use a printer, print according to your design, and then you can go through a series of tests. Now this test is following a standard called International Dysphagia Diet. And let me show, okay, this is some of the configuration we have for different kind of materials, whether it's garden pea, carrots, or pie choi. We have to work to find what is the best combination of parameters to give you an optimal design. So these are the two tests that we do to meet these standards. So there's a fork pressure test and a spoon tip test. So the idea is to ensure that the 3D printed food is actually safe for consumption for this group of dysphagic patients. So the clinical findings, we find that if you work on different kind of vegetables, there are different kind of optimization. Garden pea, we find that we can even optimize the print without the adding of hydrocolloids due to the high starch content. Now, adding hydrocolloids has got two disadvantages. Just one is, of course, it increases the cost, and secondly, it actually alters the taste a little. It can be a bit flat. So all this actually allow you to come up with a formula or a recipe to print different kind of materials in an optimal way. And this is a picture of what we call the puree diet. So you can see you can have your garden peas, you can have your mashed potato, you can also have your proteins coming out from your fish or your meat. Yeah, and you can see they're all in puree form, so very safe for consumption. Now, moving on to the third area, we have also worked on alternative ingredients. So you can see that actually you can get your proteins from insects. You can see here from your crickets, or you can get it from your plants, so algae, fungi, and seaweed. So we have begun work in this area as well. So we have started to work with cricket flour that you see here. So we have purchased a cricket flour, and then we put it through our food printer, and we are able to print lattice structure that you see on the right-hand side successfully. So this is something that we can do as well. Now, this is the last but not least important area, waste. So worldwide, as I said earlier, 1/3 of the food produced is wasted. For instance, in the Netherlands, the most wasted food is bread. In Singapore, I think we have vegetables or fruits that are often thrown away because they are ugly or they are too ripe. Upprinting of food is a very important way to bring the residual food flow back into delicious tasting and looking food. So for instance, we have done quite a fair bit of work in this area. So this is an example done by one of my colleagues on jackfruit seed. So basically, if you look at jackfruit seed, we normally eat the jackfruit and then we throw away the seed. But the seed are actually rich in termine and actually riboflavin, which means it's actually potassium as well as vitamin B. And when after you're 3D printed in shapes like this, you can actually eat it, and you find that the taste is quite like chestnuts. This is another big area because in Singapore, we consume a lot of tofu or your soybean products. So the result of making tofu is byproduct okara. And again, you can see the okara on the left-hand side. So we have made use of this okara instead of just allowing it to be thrown away and turn it into dishes that can be used. So you can see that we have published a paper in ACS Food Science and Technology making use of okara. Now, what's next in 3D food printing? I think it's very important to work on the texture as well, so that if you use printing, you can print, let's say, helically, you can actually increase the crispiness. You can have 7 fracture points that increase the texture. We can look at personalized food, not just for hospital, but even all the homes. So you look at the homes which are a lot nursing homes all around the world, and given the aging society that many of us will go through, especially Singapore, you'll find that there are a lot of people with this kind of particular needs. And then there are people like soldiers and sportsmen with very specialized nutritional needs. And in the area of sustainability, we are looking at alternative protein and of course to reduce the food waste. And last but not least, the use of Industry 4.0 technology to be immersed into 3D food printing to give it a broader coverage of digital gastronomy. Now, there's a fifth area which I did not cover in this presentation, but way back when we celebrated SG50, I was asked to write in a column for Straits Times. So this was the article I wrote. Do you still need cows if you can 3D print beef slices? So the focus of this is not so much because of disease. It's not because of mad cow or is it bird flu, but it's more of carbon footprint. To grow a calf to a cow takes years, and it takes a lot of sunlight, it takes a lot of pasture, it takes a lot of water. So you are actually creating that carbon footprint. So the whole idea is to reduce. So if you can take a cell from the cow, a cell from your chicken, and bioprint it, you find that you can actually save as much as 80% in terms of carbon footprint for cows, and for chicken, maybe lesser, about 20-30%. So the main motivation in this area is really about saving Mother Earth. Let me just share a little bit about what SUTD has also been doing to excite people like you in the JCs, in the polys, and even in the secondary school. So in recent times, actually all this happened in this year, we have done two competitions in the area of 3D printing. The one that's more relevant to this topic is we have done a digital competition, digital food competition with the support of Armstrong, OCBC, and the Singapore Food Agency. So in my earlier discussion, our focus was on yam, mainly because the donor, Armstrong, is a Hakka and I'm a Teochew, so we thought that perhaps we can print yam. So that was the first episode where we printed yam. I think I have a slideshow, I'll show it to you later. And very much formatted like the MasterChef, we have a second episode, which was more the interest of OCBC and SFA. Can we deal with food waste? So in episode 2, we look at vegetable waste. Now, vegetable waste means that from the local farms, they actually use the leafy part, but the stems and the stalks, they throw it away. So our idea was to bring these stalks and stems back into the food chain, and we gave the challenge to the students. And a total of 3 teams from Poly and 3 teams from JCs were selected, and then they'll be honored at a conference which I'll organize next month. I'll share you more details. So like I've said, basically the inspiration for printing competition came about from this another show that you can see on Netflix. Is called Baking Impossible, where they combine engineering with baking. Mine is a little different from theirs. Ours is not baking engineering, but using 3D printing and engineering. So similar to their version where they have a total of 8 elimination rounds. So like Squid Game, you remember, the participants are being eliminated. So in this case, every episode someone is eliminated, but with a very interesting engineering team. So the boat, for instance, in the first episode that the print must actually survive the floating through the canal. At the same time, the entire food is actually edible. So very interesting concept, but we did it with our 3D food printing. So let me share a little bit on a broader aspect that we are doing in the area of digital gastronomy. So I think it's important for education to excite students like you, so that if you're interested to even do a sandbox, come and discover the innovator and you come and intern with us. I'm organizing a global international conference next month, and one of the focus themes is actually healthcare. We have generated a lot of publicity on CNA and Singapore. In fact, CNA just broadcast a half-an-hour section in the last 2 nights on our competition. And of course, we have sponsorship from Armstrong, SFA, and OCBC. But we are also doing research to generate very high quality journal papers. We're creating the deep tech so that we can move on to entrepreneurship. So we are now actually doing test bidding with our Digital Chef 1.0, our own in-house printer. So we are deploying our own printer and we are testing our dishes with nursing homes. And on the left-hand side, you can see we are very privileged that Minister of Health, Mr. Ong, has actually crafted the foreword for our forthcoming book. This will also be launched at our conference. This is the 10th book I've written. I think it's the first time I have a foreword written by a minister. Let me just move on to this part. So of course, we are very well covered by Taobao. I thought I'll show you this slideshow. So actually, there were 26 teams that participated in the episode 1, focusing on yam, and then the top 6 team has moved on to episode 2, which is the vegetable waste. Let me skip this. I realize my time is running out. Let me just spend a few more minutes to talk about our conference. So it's a conference I'm organizing next month. And then, of course, we launch our book. And I have 20 gurus from around the world coming to speak on very, very exciting topics. For instance, my colleague is going to talk about the circular economy, because today a lot of things we are doing is linear, and a lot of things actually after you find that your handphone or whatever is not working anymore, just throw it away. Can we design such that we bring it back into the economy? Unfortunately, this one is not happening because of the war. Let me move on to my good friend Charlotte. Charlotte will be here to share about 3D printing of corals, and this is all because of climate change. In the Red Sea, a lot of the marine life is now affected. And can we actually print corals to bring back and then revive the marine life? So this is the work that's been done in Red Sea, and Charlotte will be coming to the conference to share. This is the work that I've been doing with Kutikwa Hospital, and Gladys will be sharing quite a bit of what I've talked just now, all the different vegetables that we're printing, including the fish that you see at the bottom. Now, looking to the future, I hope one day we will have 3D food printing as a store in SUTD. You can see 2 of my colleagues here. One is a local Chinese, the other is a Japanese. Therefore, very ably, I call it a Japanese and Chinese store. Can we bring AI into 3D printing? Yes, we can. I hope that we will also go to commercialize what we're doing. Perhaps we'll start with a pony, and hopefully one day we'll become a unicorn. If we can't, we'll start printing the horn and the wings. So the program I just mentioned, CNA has just broadcast us last 2 nights. If you have time, go and take a look at Food for Life 3D Nation. Yeah, that was 2 nights ago. And now one of the things I found in Singapore, that we have been losing all our favorite pastries. More than 11 years ago, one of my favorite Teochew pastries, Muili Close Shop, I lost my favorite Teochew Pia. And I think last year we lost my favorite Mati, so which is basically a Hokkien. And then recently, I think there's one which is more the Nyonya Kueh. So we are losing all these folks because in this industry, a lot of it is very manual. Many of them spend hours and hours on their feet. And it's a very hot environment because they use oven and all that. And you will find that more and more of this will disappear. But if we can bring automation back into this kind of industry, perhaps we can salvage and save many of our heritage in food. I will skip this. Yeah, in view of time, I will skip all these slides. And I just want to say that in 3D printing, we are just merely at the surface. We are, so it's just at the tip of the iceberg. There are a lot more things that we do not know, despite having in this field for more than 30 years. I think it will be around for the next 50 years. My vision is one day we can make a food printer as commonplace as a coffee maker. We can actually customize according to the sensors that we have, starting with the eye aesthetically, to the nose aromatic, to the mouth appetizing, and most of all to protect the heart, making it nutritious, delicious at the same time, protecting the heart safe. So I hope we can optimize our dining experience, our pleasure, and bring delight as well as good health to us. So with that, I will just pause here. I'm available on WhatsApp, WeChat, Instagram, Line, all the different social media you can think of. And I'll welcome any questions that you may have now. I will stop sharing. So Samuel, sorry, I've taken a lot more time, but I'm now open for Q&A.
Thank you, Prof. It's really exciting. I especially love the term digital gastronomy. I think that's really, it speaks to the heart of a lot of Singaporeans, right? We love food, and now we are digitalizing this aspect.
Indeed. Yeah, that's what Minister Ong wrote in his forward. He said food is a passion for Singaporeans.
Can't go wrong, once we start on the topic of food.
Yeah. And after 32 years in this area, I that's why I titled this talk on the next frontier. Really, food is really the next frontier that we should focus on.
We have two questions in the Q&A, but before I move on, okay, the third question just came in. But maybe before moving on, maybe I can ask a broader question, right? I know you covered this in part in your presentation, but Singapore has a 30 by 30 goal, which is to meet our 30% of our nutritional needs by the year 2030. What do you think is the potential for 3D footprinting, right, in Singapore to help enhance our drive towards this vision 30 by 30?
Yeah, so if you look at 30 by 30 vision, it's very much driven by Singapore Food Agency. And that's why in our competition, when I work with them, they were very interested in episode 2, not so much on the EM, but more on the food waste. So they told us there are two very important agenda for them is local produce and sustainability in terms of the food waste. So, and that's why we've chosen the vegetable waste to work on, and we work with a local farm. So my view is that we definitely can play a role in helping SFA to achieve this 30 by 30 vision. Now, moving on to what we have just asked Samuel, I saw that the first question talking about traditional means of growing food. Now, I just want to explain that in the food chain, our work is not in the front end. That means we don't look at urban farming. We actually look at the middle part, which is processing. We are coming up with non-traditional way to process your food. So the growing part, where the ingredients come from, whether it's at the top of your HDB block or for your traditional farms, it's not our focus. So I hope that will answer the first part. We are not looking at growing food. So we need ingredients to come into our food printer. And I move on to the second question about how power intensive is, for example, to produce enough for one food. Now, today I acknowledge the food printing is far too slow. And what we are doing in SUTD is to come out the world's fastest food printer. And why are we developing this? For another very important reason, not only to own the IP, but really to bring the cost down. Like I've said, I've been in this field for 30 odd years. We printed metals, I printed polymer, I printed concrete, I printed cells, living cells for tissue and organ. In many of these areas, one of the biggest impediments or hurdles to getting mass adoption is cost. So you'll find that some of these metal printers, in fact, most of them are above $1 million. I bought something like 6 metal printers ranging from 1 million to 2.5 million. So when you have a printer that's millions, you will naturally find that everything you print out of the metal part is very expensive. So it only makes sense if that product you're trying to do is high value. Otherwise, it doesn't make sense. And that's why the two most popular industries that metal printing appeals to is aerospace and medical, because the implant is very expensive. A part in the aerospace is very expensive, and it makes sense. But if I now can develop the food printer in SUTD, because it's developed by us, I can manage the cost, I can bring it down. And if I want to flood the market in terms of volume, hoping that one day every home will have one, every school will have multiples, then you'll find that with volume, you can actually bring the cost down. And once you have more printers, you can actually also bring down the cost of the ingredients. So which means there are a lot of food in, and I hope to generate a whole new industry of SMEs that can supply all your food in different capsules form, like like a coffee maker or even in cartridges. So the whole idea is today it's not there, but that's my vision, that we can really bring this about. Hopefully in my lifetime, Samuel, that I can see this happening. But in terms of power, I think it's very much a power that you use for any printer. Now, what sort of technological revolution? I think there are a lot of challenges. Now, if you look at extrusion base, which is very much used for food, it suffers from two very severe limitations. One is speed. If you are familiar with 3D printing, you find extrusion is very slow. Years ago, I did a benchmark for a ST company, and we're looking at a part which is at the base of an army tank. It's called a bionic. So this part is about this size, and I tested it with 4 or 5 different technologies. The extrusion base was the slowest. It took like 3-4 days to print one part. Others can do it within a day. So extrusion is very slow. Second, it has very poor resolution compared to SLA many. If you're familiar with all these technologies, I think you understand me. It is far too slow. So slow and poor resolution actually does not make FDM a very good technology to do food printing. But then all of you will ask me, hey, why is everybody using extrusion? I can tell you why. Because it's the cheapest printer right now. If you look at all the printing technology, the first commercial printer was 1988. All right, 1988, first commercial printer. FDM came out of extrusion base, came out around 1992. At the time, each of these printers is about $200,000 to $300,000 US. But among all the patents, this was the first to expire. After it expired, all the companies, including me, we jump on the bandwagon to spin off company and come up with many extrusion-based printers. So I have one as well, many years ago, developed one. So it is something that is already out there, extrusion, very affordable. Many schools have it. And it even now costs only within a few $100 you can get a printer like that. So that's why a lot of people use to print food. So extrusion is quite easy to use. I just want to emphasize, this is a book I first wrote. I've written 10 books now. This is my first of the 10 books. Can you see the word there, Samuel? What is it called?
It's rapid prototyping.
All right. And if you go back to the old days, can you recognize this? CD-ROM. So this was my first book written in 1997. Of course, over the years, I've released altogether 5 editions. So my latest is 5th edition. I've called it Additive Manufacturing or 3D Printing. So it has evolved over the years, and definitely the challenges today are cost, speed. These are the 2 main challenges. Accuracy is not so key, unlike in certain technology, because food, if you 1 mm off, it's not going to make a big difference. So it's not like in electronics, we even go to nano, because it's talking about, electronics, they are so much smaller. Now, how ready are consumers accepting the idea that food could be 3D printed? Not there yet. So in my team, I have a social scientist who's looking at the acceptance of 3D printed food. So it is very much human behavior, the nudging. And one of the things I did not share just now during my presentation is when I organized this competition, one of the risks I faced was, what if I have a case of food poisoning? So this is something in the mind of many people. Is it safe to consume? So what I did in order to convince my management that it is viable, when I did this competition, Samuel, is worth us. I don't think anybody has done it. And how did I mitigate the risk? Firstly, I use food safe printers. So I use commercially available printers that comes with the food safe from the vendors. So we know it's just like your usual microwave oven. A lot of kitchen appliances you use, you just put your food in, right? You never think about safety. This is the kind of food printer we use. Secondly, don't believe what the vendors say. So I actually take the food, measure the bacteria, put it in and print, take it out, again measure the bacteria and find that no bacteria were added. So confirm the food printer is safe. It did not add anything to it. All right. So guaranteed. Third is that when we did this competition, while we choose every team 2 students from a JC or a poly, we added a third member of a team from this Sunrise Global Chef Academy. They are training polytechnic level students, diploma level basically, to meet the demand of chefs for Singapore. They started about 11 years ago. It was because at the time we started 2 integrated resorts. Then we realized that having Shartech alone is not enough. So they started this private school to train chefs. And I partnered with them, with their founder, because if I have a third member who is a student chef, then I'm very sure it's going to be safe, right? If you are starting to be a chef, how can the food not be safe? So very important is the preparation. So with that, I actually brought in a SFA to do a briefing to all our participants about food preparation, food hygiene, and food safety. So I did these 4 things to make sure that during our competition, nobody suffers from food poisoning. Otherwise, I lose my job, you know. So food acceptance, I think today is not something that many people accept, because I think people still go to the kitchen and whip out a dish without going to a software, right? But I think the day will come, and I hope in my lifetime, I will see this really happening, very, very massively adopted. Now, someone asked about how can Polytechnic work as using a 3D food printing? What are the possible avenues? Internship. We started a sandbox program last year, and this year, in fact, 2 of the students both are from the JCs. They came and interned at my lab. So the idea is that we get them involved, and it's very real work, because what are the students doing? They're actually printing dishes now for the nursing home. So we are actually test bedding our product. You can print something, and how do you know they like it, right? So the best is go to the consumer themselves and then find out, is this something that meet their requirements? And if not, we go back and fine tune. So this is something we are doing right now. And I welcome, if you're from the poly, you're interested, my email there, my WhatsApp is there, just drop me anytime you want, and we can look up for opportunities.
Can they participate in the upcoming conference that you're going to organize?
Okay, good question. I tell you what, because our conference, we have 200 speakers now. They are all paying, except the gurus, the keynote speakers. Now, I tell you what, I made an exception. Drop me an email, because I don't want to open the floodgate such that I have a lot of people, then I don't know whether the bandwidth can work or not. Ours is a hybrid event. So if you're in Singapore, it's best you can come physically. But of course, that means that it will incur higher cost on my tea break and lunches. So I have to say yes in a very cautious way, because no matter what, budget is still an issue. But if you are paying, then no issue at all. You are paying for the conference, I warmly welcome you. But you are coming in free of charge. I have to, like I say, cautiously say yes. But the exhibition is free. So we have conference come exhibition, and I have 16 vendors coming to exhibit their products. So these are mainly all the 3D printing vendors selling either the machine or the materials, and some are of course providing services. So exhibition free from the first day afternoon of the conference on 23rd August to the last day by noon, 25th August. Please come to SUTD, to the campus central. You can move around. Our posters will be there to show you what we are doing. I think maybe I'll be selling some of my books if you're interested to buy our latest copy of this digital gastronomy book. Is printing or 3D printers a possibility? Yes, this has been around for a long, long time. The idea of using printer to print themselves, yes, it has been around. And there are people who put up on the free open domain, all the design of printer, you can just make one yourself. Yes, it's been out there. In what way can AI be used? 3 ways. First, you can use AI to optimize the material. Second, you can use AI to optimize the design. So I can give you an example of what we have done in design. So I've actually been working on a separate project on printing an electric vehicle. So 2 of the items we did, the steering wheel as well as the side mirror, we use generative design. So the parts that you print are both lightweight and aesthetically very pleasing to the eyes, but they are still functional. So we use AI. So generative design is an AI algorithm. So you can generate many designs and see which is the one you like, yet it will meet all your functions. Aesthetically, it looks fantastic, very nice. So that can be my sideline when I retire, to sell car accessories. All right, so that's the second. The third is the process. all the printing process are not straightforward. They are very high order mathematical control to optimize the process. You can use AI machine learning, you definitely can collect all the data and optimize the process. So what do you want faster? Yes, you can look at speed as one optimal function. You said 3D food printing can be used to prevent food waste. However, what about food waste produced from 3D printing, leftover from cutting, food printing? All right, now 3D printing inherently saves material. If you look at before the birth of 3D printing in 1980s, the predominantly used technology were subtractive as well as formative. So subtractive is used very much in prototyping in all industries. Whether you are making a rocket to your handphone, you always need a prototype. And how do you make a prototype? They take a block of material, whether it's wood, clay, or some plastics. They will use a cutter to machine it. What do you end up with? A lot of chips, a lot of waste. So when we conceptualized 3D printing in the 1980s, the whole idea was you make what is only required. So as much as you can, for instance, you're doing a bottle, you use exactly the amount of material needed. Imagine if I were to make by the subtractive method, I'll need a block material and machine all this waste. So inherently 3D printing is already a method that saves material. That's why it's very popular in all the industries. Now, will there be a bit of food waste? Yes, if you need support, then this support will be a waste. So there will always be some amount of waste, but you compare it with subtractive or formative, you'll find that already is saving a lot of waste. So I hope I have answered your question. Samuel, any more?
So I think we have one more question in the Q&A and another in the chat. So the one in the Q&A is, what kind of opportunities do you see that will be brought about by advancement in 3D printing?
I think if we can make it faster, make it affordable, you will find that 3D food printing is disruptive. A bit like your Grab, right? When in the past, we all talk about taking a cab. But when Uber and all these industries come, they actually disrupt the taxi industry. Then, of course, Airbnb, when you travel, you find that you used to stay in hotels, but now actually you can stay in residence. So you find that 3D printing plays in the same area as a disruptive technology. Now, it will disrupt the way we think about food. Today, nothing is digital, but I'm actually emphasizing that we can go digital. Once you go digital, it is powerful because your digital design can be downloaded anywhere in the world. I envisage a day where you can basically, in your kitchen, download a menu, work on it, come up with a better dish, sell your dish online. Someone else around the world may just buy your dish. I envisage a day there will be a lot of companies supplying all the different printers, the different food ink. I envisage a day where the affordable printers will flood the market in terms of home schools, but the more atas printers can be used in the sophisticated restaurants where they need multiple print head or different functions like heating and things like that. This is the kind of opportunities I'm looking at in the future. It's not there today, but I think it will come. Which country will advance significantly? Does this mean it will be a huge technological advantage for military for that particular country? Yes, I've already seen a printer being developed in the Netherlands for the military. It's a huge printer with hundreds of print heads. Each print head coming up printing a specific snack for a soldier, customized to the physiological data of the soldier. Now, all these are being done to address the issue of scalability. Can you have a big printer with multiple print heads? Technically, yes, but of course, you still have issues of control, mechatronics, and software. Can it improve the quality of life? Yes, I think it has tremendous potential. It can really be what PM Lee has been saying lately. Can we be disruptive? Can we create new growth areas? Today, there is no such thing as a whole area of digital food. I think we can be the first to move in this area. Now, I say it as if it's very easy. It's not easy. There's a lot of science involved. I hope that we can quantify in all those aspects that I spoke about, right? From aesthetics to aromatic to your appetizing. Can every of these aspects be quantified such that you can have a factor, and then plus the nutritional, the value that give you health. If I can combine all these 4 factors into a single equation, I can come up with a CHOA index. I hope to make that happen before I retire. Yeah. Any more, Samuel?
Yeah, I think one last one, since you're coming almost 1 hour is up already. Just maybe excite our taste buds, right? What is the next food ingredient that you're working on? So you have worked on yam. Yeah. What's next? Yeah.
Okay, recently one of our PhD students is working on durian husk. Not on durian, but when you consume durian, you end up with a lot of husk, right, which is thrown away. In fact, the husk itself has got some value as well. So that's the latest one of our PhD students is doing. I've just recruited a PhD student who will come in September. I've asked her to also look on food waste. I think either food waste or even alternative proteins, this will be 2 very exciting areas to address the issue about food sustainability, something that Singapore wants, the 30 by 30 goal. But on the more commercializable area, we are working actively with several nursing homes so that we can really test bake our dishes to meet the needs of the real consumers in the nursing homes. If we can do it successfully, we hope that this spin-off will move on to things. So we can print a lot of things, but I think you have to start with something in a realistic manner. Can we make sure that our product will be useful to this specific group? And we are trying to address one very important area, very pertinent to Singapore, the aging society. So more and more, including me, will go into this space of being 65 and above, that this group will become bigger and bigger, and more of us will need this kind of diet. Yeah, that is my current immediate focus.
Okay. And that's good to hear. And durian is in season now, so you end up with a lot of husk.
Yeah, actually, there are so many things we can work on. You know, I have one very famous media corp artist approaching us a few months ago when he saw an article. He said he's working on a book, a children's book with characters. So he's thinking of bringing to life all these characters by 3D printing figurines. So I can tell you there are many exciting ideas that people can come up. But I don't have the bandwidth, because if you tell me, Prof, print this, print that, print Mickey Mouse, print Eiffel Tower, after a while, if there's no real market, it's not going to help us in the demand. So if you have some exciting ideas, think in terms of also the demand. Is there a real demand in it? So that eventually, whatever good things we can bring to pass, there must be a market for it. Yeah.
Yeah, that's great. So if anyone of you are interested, you can get in touch with Prof. Chua. I think he has given all his social media and even WhatsApp number, right? You can get in touch with him or email him. Yes.
Okay, I've just typed in my phone number. But I think it's only to hosts and panelists. Does it go to the audience?
I can put it out for everyone.
Yeah, you help me put it to everyone. So I'm on WhatsApp. I am a workaholic, so you'll find that I reply in all unearthly hours, including weekends. But don't worry, you don't have to reply to me instantaneously. Yeah. Oh, can we 3D print more land? We need sand to print. Now, one of the things that, not in food, but more in the area of building and construction, years ago, in fact, I've 3D printed an entire bathroom unit to this ceiling height, all in 11 hours, the entire concrete structure. Now, one of the very exciting areas that people working in building and construction is in some remote areas like Sahara Desert. Can I just use the sand there and then to make structures instead of relying on more sand? Right? We run to a crunch, right? Not enough sand to do our building. Yeah. So printing more land is more about reclamation, which is also a very sensitive topic. But printing, building, construction is a very exciting and important area for Singapore. You know what I mean, right? Because that we can become less reliant on workers. Okay, I think this can go on and on. I better stop here.
Thank you very much for your sharing today. So this concludes this episode of the City Pioneer webinar series, and thank Prof. Chua for for taking his time in the morning to walk us through 3D food printing. Okay, so thank you for joining us, and we hope you have a good weekend, long weekend. Thank you.
Bye.
Bye, everyone.